Very good morning students, welcome to science session. Today in this session we will be dealing with Unit 5 Acoustics, solve problems and the numerical problems of the book by exercise. Hope you remember that we have completed this lesson. Today in this session we will be dealing with the solve problems and the numerical problems of the book back exercise. Let's get started with the session. A very good morning students, welcome to science session. Today in this session we'll be dealing with unit 5 acoustics, solve problems and the numerical problems at the book back exercise. Hope you remember that we have completed this lesson. Today in this session we'll be dealing with the solved problems and the numerical problems at the book back exercise. Let's get started with the session, children. Now let's see the first solved problems in your textbook, that is under the lesson unit 5 acoustics. The first question is, look into the screen children. At what temperature will the velocity of the sound in the air be double the velocity of the sound in air at 0 degrees C? Now here the temperature is given, that is T is given to be 0 degrees C, but we have to convert it to Kelvin, right? Now let V1 and V2 be the two velocities, right? So velocities at the temperature T1 and T2, and this should be represented in Kelvin, right? The unit that we are going to use is Kelvin, right? So what will be T1? T1 will be what is given 0 degrees C. So we are representing in terms of Kelvin, isn't it? So this will be 273 Kelvin is the initial temperature at 0 degrees C, right? Now what will be this temperature? So this is what we are going to find out, isn't it? Let this be 0 degrees C plus 273, because this has to be represented in terms of Kelvin. So whatever be the temperature, we have to add it with 273, right? Now what is given actually? It is given that what will be the temperature when the velocity in the air be double the velocity in air at 0 degrees C, right? So we said that V1 and V2 be the velocity of the sound at the temperature T1 and T2, isn't it? So V2 divided by V1 is equal to 2, because it is double the velocity of the sound in air at 0 degrees C, isn't it? Now we know the equation that V2 divided by V1 is equal to square root of T2 divided by T1, isn't it? So this is what the formula that we are going to substitute, isn't it? So we are going to substitute in this formula, right? So what we have to substitute? V2 divided by V1 is equal to square root of T2 divided by T1, right? Now we know that T2 is nothing but 273 plus T divided by what is T1, that is the initial temperature 273, and what it is equal to 2, that is what is given, isn't it? So to remove this square root, we can square on both the sides. So squaring on both the sides will remove this square root. So you will get 273 plus T divided by 273 is equal to, so this side when you square it, the square root get removed, and this side when you square it, it will become 2 square will become 4, right? So we can rearrange this equation to find out the temperature. So it's given that 273 plus T divided by 273 is equal to 4. Now I'll bring this 273 to the other side. So 273 plus T is equal to 4 into 273. So T is equal to, this is what we are going to find out, right? So T is equal to 273 into 4 minus 273. Now this, when it comes to the other side, it will become minus. So when you simplify this, you will get 819 degrees C. So that is, we are converting in terms of degree C. At the temperature 819, velocity of the sound will be double the velocity of the sound at 0 degree C. Now look into the second question, children. The second question is, a source producing a sound of frequency in 90 Hz is approaching a stationary listener with a speed equal to 1/10th of the speed of this sound. What will be the frequency heard by the listener, right? Now here what is given? Given is the frequency of the source. The frequency of the source n is equal to 90 Hertz, right? The velocity of the source Vs is equal to 1/10th into V. That is what is given, isn't it? 1/10th the speed of the sound. Let's this be the speed of the sound. So Vs, that is the velocity of the sound, will be 1/10th into V. So this is what is given, right? Now, when the source is moving towards the listener, right? When the source is moving towards the listener, the apparent frequency is given by the expression n dash. So this is the apparent frequency is equal to V divided by V minus Vs into the frequency of the source, right? Now here we are going to substitute what is Vs and the frequency of the sound, right? Now if you substitute, you will get n dash is equal to V divided by V minus, what is Vs? 1/10 into V, isn't it? Into the frequency of the source, that is 90, right? Now here we can take the LCM, right? So what will be this denominator? V minus V divided by 10, right? Into 90, right? Now we'll take the LCM of the denominator. So it will be n dash is equal to V divided by, now the LCM will be 10. So here it will be 10V minus V into 90, right? So this will become V divided by, so when you subtract 10V minus V, it will be 9V divided by 10 into 90. Right? Now this is in the denominator form. Let's bring it to the multiplication form. So this will become V into 10 divided by 9V into 90. So we can cancel this V, isn't it? Apparent frequency is equal to 10 into 90 divided by 9. Now shall I cancel this by 10? So 10 into 10 will be 100 Hertz. So this is the apparent frequency heard by the listener. So this is the frequency heard by the listener. Now at the last you will end or give the result as the frequency heard by the listener is equal to 100 Hertz. So this is how you have to present the numerical problem. First you have to give what is given, what is to be found out, and what is the solution, and at the last result. Now the third question is, a source producing a sound of frequency 500 Hz is moving towards a listener with a velocity of 30 meter per second. The speed of the sound is 330 meter per second. What will be the frequency heard by the listener? Again here the apparent frequency is asked, right? Now what is given? The given is the frequency of the source, that is 500 Hertz, right? Now the velocity of the sound is given as 330 meter per second. Velocity of the source is given as 30 meter per second, right? Now we have to find out the apparent frequency. Now here the source is moving towards the listener, that is the source is moving towards the listener. So what will be the formula? The formula is n dash is equal to V divided by V minus Vs into n, that is the frequency of the source. Now everything is given directly, right? Velocity is 330 meter per second. Again here 330 meter per second. Velocity of the source is 30 into the frequency of the source is 500. Now let's simplify this. So n dash is equal to 330 divided by 330 minus 30 is 300 into 500, that is the frequency of the source. Let's cancel these two zeros. So this will become 330 divided by 3 into 5. Now let me cancel this. So this will become 110. So it is 110 into 5. So what will be the answer? It is 550 hertz, right? The unit is hertz, right? So the frequency, that is the apparent frequency, is 550 hertz. Now the fourth question is, a source of sound is moving with a velocity of 50 meter per second towards a stationary listener. The listener measures the frequency of the source as 1000 hertz. What will be the apparent frequency of the source when it is moving away from the listener after crossing him? And the velocity of the sound in the medium is given as 330 meter per second. So here the source is moving towards the listener. Source is moving towards the listener, right? So the formula will be same as that we have used in the question number 3. Now what is given? What are the other data that is given? The velocity of the source, that is Vs, is given as 50 meter per second, isn't it? Yes. And what is V? V is equal to 330 meter per second. Now here the apparent frequency is given, right? So this is the listener measures the frequency of the source as 1000 hertz, right? So N is given, N dash, that is the apparent frequency, is given as 1000 hertz, right? Now what do we have to find out? We have to find out N, that is the frequency of the source, right? Now let's see the formula. So N dash is equal to V divided by V minus Vs into N. Now here the apparent frequency is given as 1000. And what is V? 330 divided by 330 minus 50 into N. 1000 is equal to 330 N divided by 280. Now what is this 280? When you subtract 330 minus 50, it is 280. Now we can bring this 280 to the left hand side, right? Now what will be the equation? 1000 into 280 is equal to 330 N. Now we have to find out N. So N is equal to 1000 into 280 divided by 330. So when you multiply this, you will get 280,000 divided by 330. You can cancel this and you will get 28000 divided by 33. So when you divide this, you will get N is equal to 848.48 hertz. So we are getting 28000 divided by 33. I'll cancel 11 table. This will go 3 times and this will be 254.5.3. Right? Now again when we cancel it by 3 table, right? I'm cancelling it with 3 table. So this will become 8, 4, 8s are and 4. So what is the frequency? The frequency of the source is 848.4 hertz. Now we have found out the actual frequency of the sound, isn't it? So what is the actual frequency of the sound? 848.48. So this is the actual frequency of this sound, right? So when the source is moving away from the listener, now what will be the apparent frequency? Using this frequency of the source, we are going to find out. Actually in the question, it was heard by the listener as it was predicted, it was measured as 1000 hertz, isn't it? But this is the actual frequency of the source, right? Now what is the apparent frequency? Now what is the apparent frequency? Since the source is moving away from the listener, we divided by V plus Vs. Since the source is moving away from the listener, it is moving after it is crossing him, isn't it? So this will be the source moving away from the listener. So this is V divided by V plus Vs into the frequency of the sound. That is what we have found out, isn't it? So substituting the value of V as 330 and Vs as 50 and multiplying it with the frequency of the source, that is 848.48, we will get the apparent frequency to be 736.4 Hertz, right? So this is the apparent frequency of the listener. Is that clear, children? Now let's move to the fifth question. A source and the listener are both moving towards each other with a speed v divided by 10, where v is the velocity of the sound. If the frequency of the note emitted by the source is f, what will be the frequency heard by the listener? Now here the source and the listener are moving towards one another. That is, the source and the listener are moving towards each other, isn't it? So what will be the frequency? Here we know the formula, n dash is equal to v divided by vl, that is the listener's velocity, v minus vs into the frequency of the source, right? So in this formula we will substitute vl to be v divided by 10 and the vs, that is the velocity of the source, to be v divided by 10. Why? Because they are moving towards each other with the sound, that is v divided by 10, where v is the velocity of the sound, that is 1/10 the velocity of the sound, right? So substituting v and vs as v divided by 10, let's do the calculation. And here the frequency of the note emitted by the source is f. So here this f is nothing but the frequency of the source, right? So here n is equal to f. Now here we are getting n is equal to f. So we will substitute in this equation. So n dash is equal to v plus v divided by 10 divided by v minus v divided by 10 into, instead of n, we are going to substitute f, right? Now let's take the LCM for the denominator as well as for the numerator. Now what will be the equation? N dash is equal to, the LCM here will be 10. So this is 10v plus v divided by, here the LCM will be 10. Here it is 10v minus v, isn't it? Into f, that is the velocity of the source, right? So here it will get, here you will get 11v divided by 10 and here it is 9v divided by 10. So n dash is equal to 11v divided by 10 divided by 9v divided by 10 into f. Now we'll bring this division form into multiplication form. So n dash is equal to 11v divided by 10 into 10 divided by 9v into f. Shall we cancel this v? 10. So we will get 11 divided by 9f. So this is the apparent frequency. Now let's move to the sixth question. At what speed should a source of sound move away from a stationary observer so that the observer finds the apparent frequency equal to half of the original frequency? Now what is given here? The source is moving towards the stationary observer. Here the listener is at rest, isn't it? So the listener is at rest and the source is moving towards the listener. And again, the apparent frequency is given as half of the frequency of the sound. So n dash is equal to n divided by 2. So this is what the data that is given, right? So we will substitute in the equation. So here we are getting the equation n dash is equal to v divided by v plus vs into n, since the source is moving towards a stationary observer, right? Now here n dash is equal to n divided by 2 is equal to v divided by v plus vs into n. Shall we cancel this n on both the sides? So what you will get? We will get v plus vs is equal to 2v, right? So vs is equal to 2v minus v. So vs is equal to v. So here the velocity of the source is equal to the velocity of the sound, right? So the speed of the sound is equal to the speed of the source. Now let's move to the numerical problems at the book back, right? Now the first question is, a sound wave has a frequency of 200 Hertz and a speed of 400 meter per second in a medium. Find the wavelength of the sound. Now here we are going to find out the wavelength of the sound. Now what is given? The frequency is given, that is n is given as 200 Hertz, right? And the speed of the sound, that is v is equal to 400 meter per second. Now what we have to find out? We have to find out lambda. So this is what is given. So we know that v is equal to n lambda, right? So this is the equation that we have learned at the beginning, isn't it? Now here we are going to find out lambda, substituting v is equal to 400 meter per second and n is equal to 200 Hertz, right? Now let's rearrange this equation. So we know that v is equal to n lambda. So what is lambda? Lambda is equal to v divided by n. Now what is v? V is equal to 400 meter per second divided by n is equal to 200 Hertz, right? So this will be equal to 2, right? So lambda, which is nothing but the wavelength, the unit is meter. So 2 meter is the wavelength of the sound wave. Now what will be the result? The wavelength of the sound wave is equal to 2 meter. Now let's move to the second question. The thunder of a cloud is heard 9.8 seconds later than the flash of lightning. If the speed of the sound in air is 330 meter per second, what will be the height of the cloud, right? Now here we are going to find out the height of the cloud. Now what is given? The speed of the sound v is given as 330 meter per second, right? Now what is the time that is given? 9.8 seconds. This is the time to hear the thunder after the lightning. Now we have to find out the height of the cloud, that is distance d is equal to v into t, isn't it? Now here directly we can substitute v and t to find out the distance. So 330 meter per second into 9.8. So when you multiply, you will get 3234 meters. So this is the height of the cloud or the distance of the cloud, right? Now the third question, right? A person who is sitting at a distance 400 meters from the source of sound is listening to a sound of 600 frequency. Find the time period between the successive compression from the source. Now here what we have to find out? We have to find out the time period t, capital T we have to find out, right? Now what is given? The frequency is given. The frequency, that is mu, is given as 600 Hertz, right? So that is what frequency is given. Now what do we have to find out? We have to find out the time period. We know that frequency mu is equal to 1 divided by t, isn't it? Now what we have to find out? We have to find out t. So t is equal to 1 divided by mu, right? Now what is 1 divided by, what is mu? Mu is 600. So when you divide this, you will get the answer. Let's see that. Now let's divide. So this is 1 divided by 600, isn't it? Now I'll keep in decimal and add a 0. Again, it is lesser, so I'll add 2 zeros, right? So 600 ones are 600. So what will be the remainder? 400. Right? Since I've taken in decimal, I can add 1 0 here. So this is 6 times. So 6 6 are 36. So 600. again I'll get 400, right? Now again I can add one more 0, right? Now this goes on, so it will go as 0.001666. It goes on, isn't it? So this can be rounded off as 0.00167, right? So what is the time period? The time period is 0.00167 seconds. The time period, the unit for time period is seconds. So that should be written. Don't forget to write the unit, children. Moving to the fourth question. An ultrasonic wave is sent from a ship towards the bottom of the sea. It is found that the time interval between the transmission and the reception of the wave is 1.6 seconds. What is the depth of the sea if the velocity of the sound in the sea water is 1400 meter per second, right? Now what is given here? It is given that the distance traveled by the sound, ultrasonic sound, and the time is also given, right? Now here we are going to find out the distance, right? So what is V? So V is equal to 1400 meter per second, right? Now what is T? T is given as 1.6 seconds, right? Now here the speed of the sound V is to be calculated, and that can be taken as 2D divided by T. Now why we are taking 2D? Because it is based on the echo, concept echo. Now here, since the ship is sending the frequency, right? Now again this frequency has to reach the ship, isn't it? So the frequency has to touch the bottom of the sea and has to reach back to the sea to find out the depth of the sea, isn't it? So the distance here traveled is twice, so it is taken as 2D, right? So here the formula is V is equal to 2D, and we are going to substitute in this equation to find out the D. So our equation is V is equal to 2D divided by T. Now what we have to find out? D. So let's move this T to the other side. So V into T divided by 2 is equal to D. So this is the equation to find out the distance. Let's substitute the value of V and T to get D. So V into T divided by 2 is equal to D. V is 1400 into T is 1.6 divided by 2. Now here I can cancel by 2, so this will become 700. 700 into 1.6 is 1120 meter, 1120 meters. So multiply 700 and 1.6, you will get 1120 meter. So the depth of the sea is 1120 meter. So moving to the fifth question. A man is standing between two vertical walls 680 meters apart. He claps his hand and hears two distinct echoes after 0.9 seconds and 1.1 second respectively. What is the speed of the sound? Now what is the situation here? You have two vertical walls and a man is standing in between the two vertical walls. Now what is the distance between the two walls? 680 meters, right? So the sound has to touch the wall and again it has to come back. So here the distance is taken as 2t. Now here you have two time, isn't it? Because you have two vertical walls, right? Now here it is 0.9, here it is 1.1, right? It is considered. So we have to add these two times. So this will be 0.9, 1.1. So this is 2.0. So 2.0 is the total time, right? And this is the distance. So we'll substitute in the formula V is equal to 2D divided by T. So we get V is equal to 2D divided by T. So 2 into 680 divided by 2. So we'll cancel these two. And what is the value? 680 meter per second. The value of the speed of the sound is 6 meter per second. So the final answer, that is the speed of the sound in the air, is 680 meter per second. The sixth question is, two observers are stationed in two boats 4.5 kilometers apart. A sound signal is sent by one underwater, reaches the other after 3 seconds. What is the speed of the sound in water? Right? So you have two boats in water and the signal is sent by one. It reaches the water underwater and it is received by the other person in boat 2, right? Now what is the speed of the sound in water? Now the time taken for this complete process is 3 seconds. And what is the distance between the two boats? It is 4.5 kilometer. Now this has to be converted into meter, isn't it? So this can be written as simply 4.5 into 10 to the power of 3 meters, isn't it? So we are converting in terms of meters, right? So what will be the answer? So this will be, after multiplying by 1000, it will be 4,500 meter, right? So this can be written as like this. Now we know that time is equal to 3 seconds. Now here V is equal to D by T. Why? Because the distance is taken as D. It did not reach the same person in boat 1, but it is received by the other person in boat 2. So the distance, the complete distance is taken as D, right? Now let's substitute in the equation. So V is equal to D divided by T, right? Now what is D? We have found out 4,500 and the time is 3 seconds, right? Now let's cancel by 3. 3 ones are 3, 3 fives are 15, 0, 0. So what is the velocity of the sound in water? 1,500 meter per second. So this is the speed of the sound in water. The seventh question is, a strong sound signal is sent from a ship towards the bottom of the sea. It is received back after 1 second. What is the depth of the sea given that speed is 1,450 meter per second? Now what is given here? The speed of the sound, that is V, is given as 1,450 meter per second, right? Now what is the T? T is equal to 1 second. Now what we have to find out? We have to find out the depth of the sea, right? No, we know. So this is also under the concept echo. So we know that V is equal to 2D divided by T. Let's substitute in this equation. So we will get D is equal to Vt divided by 2. Now what is V? 1,450 into time is 1 divided by 2. So when you cancel by 2, 2 sevens are 14, 2 twos are 4, 2 fives are 10. So what is the distance? 725 meter. So the depth of the sea is 725 meter. So far we have seen 6 solved problems and 7 numerical problems at the book back exercise. So totally we have covered 13 numerical problems. Please do copy these 13 numerical problems in your classwork. You can check the PDF. I have uploaded the PDF for the lesson Acoustics. See the PDF and copy these numerical problems. Understand these numerical problems. So work it out, because these numerical problems has to be worked out frequently. Otherwise, you will not get it, right? So please practice these numerical problems again so that you are very familiar with the concept as well as the procedure to solve the problem, right? Now copy these 13 numerical problems in your classwork and submit your classwork in the school office on Friday. We'll meet in the next session. Thank you, children.